In this video, we're going to look at the area of a triangle formula. To find the area of a triangle, we have to do a half times the base times the height. A half times the base times the height. But what we're going to do is we are going to, just briefly, we're going to zoom in on one of the two triangles that we're given at the top. We're going to zoom in on this triangle here, the triangle BCT. We are given that here is our right angle. Okay, so let's imagine that we're given this right angle, and what I'm going to do is I'm just going to do a wee sketch of the triangle at the side. Okay, so this is T, B and C, and we've got a right angle here. From the original picture, this is A, because it's still part of this triangle here, and we are given our height. What we're going to do is we're going to apply some basic Socator. I'm going to write down Socator. And essentially what I want to do is I'm going to make this the angle of interest, this one here. So if I were to label my sides as normal, this is the hypotenuse, and this is the opposite, this is the adjacent. So we would tick off what we have. We've got the opposite, we've got the hypotenuse, and we're going to be using the formula that has both. So we're going to be using the sine formula. So if I were to plug the information that I've got in my picture here, I have got sine of C is equal to the opposite, h, divided by the hypotenuse, A. And if I multiply both sides by A to get rid of the denominator of A, I'll obtain h equals A sine C. And if I can just shrink this down a little bit and move it over, what I'm going to do now is I'm going to substitute h equals A sine C, and I'm going to substitute it in place of here. So instead of having a half BH, I'm going to have a half B, and I'm going to have this expression. So let's see how this looks. The area equals a half B, and then instead of H, I'm going to substitute in A sine C, and just to make this look a wee bit nicer, we can write the area as a half AB sine C. This is the formula that we will be using to find the area of a triangle, provided that we know an angle and the length of two sides that form it. Okay, in this first problem we've been asked to calculate the area of the triangle ABC. We're given two sides and a given angle. So we're going to need to use our area of a triangle formula. So the area equals a half AB sine C. But where do we get A, B and sine C from? So if we look here, how we label the sides is, see how we've got A at this vertex here, this vertex. A is attached to these two lines, and so the line that it is not attached to is the opposite side of that. So this one here is what we're going to label A. Similarly, we're going to label this B, and opposite of C, we're going to label this C. And so we're going to apply this to our formula. So we're going to do a half times 6 times 7 times sine of 35 degrees. And if we do that on a calculator, we should find that we get an answer of 12 centimetres, and it's going to be squared because we are talking about area. So 12 centimetres squared. Okay, so the tricky part here is just identifying which sides are the opposite and so on. Apart from that, it's just a pure application of the area of a triangle formula. Okay, similar problem. We'll be asked to calculate the area of the triangle RPQ. We're given an angle and two sides that are attached to the angle or are associated with the angle, so we know we're going to need to use the area of a triangle formula. So the area of the triangle formula is A equals a half AB sine C. But what we notice here is that we do not have A, B, C. We've got P, Q and R. So step one is we label our sides. So the side opposite P, opposite Q, and then opposite R. So this would usually be our sine C part. This part here, this would usually be sine C. But in this case, it's going to be sine R. And so we're going to rewrite our formula as a half sine R, but instead of AB, it's going to be PQ. Okay, so you need to be comfortable with where we get these from and being able to interchange formula. Okay, so the area is going to be a half times 2 times 3.5 times sine of 80 degrees. And doing that on your calculator, that will come to one decimal place, 3.4, and it's an area, so it's centimetres squared. So the only thing that was different here was that we had to label our formula differently due to the corresponding letters that it gave me in the given triangle. Okay, here we've got a more complex area of a triangle formula question. Okay, so this is just taken from a previous past paper. So in the triangle PQR, we are told that QR is 6 centimetres. We are told that angle PQR is 30 degrees, and that the area of the triangle PQR is 15 square centimetres. Okay, so it's telling us the area of the triangle PQR is something. Calculate the length of PQ. So we want to know this length here. This is an area of a triangle formula question because it tells us something about the area of the triangle here. Okay, so the area, the formula is a half AB sine C, but in this case we don't have A, B and C, we've got P, R and Q. We are given the angle Q, so that means it's going to be sine Q, and it's going to be a half PR. So it's going to be a half PR sine Q. What we're going to do is we're just going to fill in the information that we know so far. We know that the area is 15 square centimetres, so we can replace A with 15. That's the same as a half times P, which is 6, and times by R, which we don't know. R is what we're looking for. This is the one of interest. And we're going to times that by sine of 30. This could potentially come up in a non-calculator paper. So how can I calculate sine of 30? If I think back to exact values, I'll just do a wee sketch here. We've got a right angle, and if we have got an equilateral triangle of side 2, and if we cut it in half, we would have 2, 1, and the height of this, using Pythagoras, 2 squared, take away 1 squared, and square root it, that would give me square root of 3. And if we were to have an equilateral triangle, all the angles would be 60 degrees. But if we were to cut the top in half, this would be 30 degrees. Okay, so let's keep going. If I want to calculate sine of 30, that means that the angle opposite 30 will be the opposite. This is the hypotenuse, this is the adjacent. So remember, sine of 30, well, to find sine, it's saw in SOHCAHTOA, so it's opposite over the hypotenuse. So sine of 30 is 1/2. You could also get that from the trig graph of sine. So what I'm going to do is I'm going to replace sine of 30 with a half. So 15 equals a half times 6 times r times 1/2. Please note, this would just be a method to do if it was non-calculator. If it was calculator, by all means, you could just type in sine 30 into your calculator and get 0.5. Okay, I'm just going to minimise this to give me some more space. And so, 15 equals a half times 6 is 3 times a half, that is 3 over 2 times by r. I can multiply both sides by 2, which is going to give me 30 equals 3r. Divide both sides by 3, which will lead on to an answer, if I just do it over here, that will lead on to an answer of r equals 10 centimetres. So here was a wee bit more problem solving. If you do 0.5 times 6 times 10 times sine of 30, we should find that the area comes out to 15, which it does. I know I've got it correct. Okay, so the thing to spot here is that you are using the area formula. You substitute in the values that you know. Here, when I derived sine of 30, I used the exact value triangle from the equilateral triangle. But if this was in a calculator, you could just do this in your calculator. And then we're just doing a wee bit of rearranging and to get to this stage here, and then that gives us r equals 10. You can check your answer by substituting it back in, and we see that, yes, it does work out, and it gives me an area of 15 square centimetres. Thank you.